for this video, we will be discussing the characteristics of the previous sequence that we have solved. Okay, so since we are talking about sequence, you all know that we have the first, second, third, fourth, fifth, and sixth based on the previous problem, right? This pertains to different offenses, and then we try to note it as 1, 2, 3, 4, 5, and 6 as the domain of our ordered list of numbers. Now, since we are talking about sequence, we all know that we have to what? We have to denote 1 as A sub 1. This is not different from 1 and first, okay? This is just another way to denote the position of the number in a sequence, okay? So we change nothing. This will just be another denotation of this particular position, which is first, okay? Now, if this is A sub 1, of course, this will be A sub 2, and then A sub 3, A sub 4, A sub 5, and A sub 6. So I think from this point, we will be using this particular denotation, okay? Because the next series of videos will be discussing how to find the different terms by just given a simple set of numbers or a sequence, okay? So let me just write it again, the sequence that we had earlier. So we have 500, and then this is 600, and then 700, 800, 900, and 1,000 pesos. Okay, so as you can see, we earlier in the previous video, we have identified that this is a sequence because we have an observed pattern. We actually have 100 pesos or 100 as the gap in this particular sequence. Therefore, it is certainly a pattern because it is fixed. Therefore, we say that this is a sequence. Now, note that we have this as we added a fixed number. Okay, so try to take note of that again. Now, I will be showing you other kinds of other sequences. Okay, let me just check my. Okay. I will be showing you other sequences whereas we added a fixed number. Okay? Example. So this is our primary sequence. Additional examples are 2, 5, 8, 11, 14, etc., etc. Okay, let's try to identify it. Now, we have a presence of an ellipsis, therefore this pertains to an infinite sequence. Okay, therefore the sequence goes on and on and on. 14 is not the last term in the sequence. Now, let's try to find if there is a relationship between the numbers. Okay, now when you see 2 and 5, the first thing that would come to your mind is, how do I get a 5 from 2? That's right there. So the thing is, how do I get this number from this number? And how to get that? You want. Pause this video. Okay, you add 3. That's correct. So you add 3 to get 5. Technically, you add 3 to 2 to get 5. What about how do you get 8 from 5? Of course, you would also be adding 3. Simple. What about 11? From 8, you will be adding also 3. From 14, you will be adding 3. Okay? So in this case, we also added a certain number, a previous term, to a fixed number to get the next number. Another example. Example 1, let's have example 2. 17, 12, 7, 2, -3, etc. Okay. Compared to the two previous examples, this one seems to be what? To be decreasing, right? From 17 it became 12, and then 7, and then 2, and then -3, etc. etc. This is also an infinite sequence because it has an ellipsis here. So as compared to this one, whereas you add 3, how do you think will be the solution for you to get 12 from 17? Pause this video. Okay. Of course, if you're thinking that we need to subtract 5 from 17 to get 12, that is correct. We just have to what? Subtract 5 to get 12. As simple as that. Okay? What about to get 7 from 12? You also what? You also subtract 5. Also, for you to get 2 from 7, you also need to subtract 5. And then, of course, for you to get -3 from 2, you need to what? Subtract 5 again. So in this case, it is also fixed, but sir, isn't it not the same as the two previous examples because we added a fixed number? In this case, yes, we also add it. This is also what? This could also be interpreted as what? Plus -5, plus -5, plus -5, plus -5. Remember, when you add -5 to 17, you also get 12. When you add -5 to 12, you get 7. When you add -5 to 7, you also get 2. You get 2. When you add -5 to 2, you will get -3. So in this case, they will be having the same characteristics. We also added a fixed number, but in this case, the number is a negative number. But it is also correct that it is also a correct thinking that you think that you will just be subtracting 5. But for me to say that these 3 are they have exactly the same characteristics, I have to input here plus -5. It will not change anything. That is the same thought. That is the same process of thinking. Okay? Now, let's have another example. For instance, we have example 3. We have 5. This will be very easy. Let's have 8, 6, 4, 2, 0, -2. Okay? So, similar to the second example, this one is also decreasing. Okay? So now, let's try to find if the gaps are also fixed. Okay? So now, how do you get 6? So, same process of thought. We have how do you get 6 from 8? So that will just be what? -2, correct? 8 minus 2 is 6. Next, 6 minus what is 4? So 6 minus 2 is 4. And then, how do you get 2 from 4? Of course, it's -2. And then, how do you get 0 from 2? That's -2, and then -2, etc., etc. So in this case, we also subtract a fixed number, but as I've told you, this will be written as plus -2 plus plus plus. But if you're more comfortable with -2, it's okay. Okay. Now, this sets of examples have one particular characteristic in common, which is what? We add a fixed number to the previous term to get the next term. And then that term will be added with the same number that was added to the previous one to get the next and the next and the next number. Okay? Excuse me. So as you all know, we added a fixed number to each sequence, to each term to get the next term. Okay, and my dear students, this kind of sequence, of course, this is a sequence. This kind of sequence is called an arithmetic sequence. Now, try to write on your notebook your own definition of an arithmetic sequence based on the following. Pause the video and try to write your own definition and check if your definition later is correct. Okay? Pause it now. Okay, so if your definition is what? If your definition is arithmetic sequence is a kind of sequence wherein you add a fixed number to the previous number to get the next number, then your definition is definitely correct. Okay? So that is how you define an arithmetic sequence. You just have to add a fixed number, in this case 3, 5, and then -2, to the previous term to get the next one. That is technically arithmetic sequence. Now, for the formal definition, a sequence in which constant d is added to the previous term to get the next term is called an arithmetic sequence. Okay? So, it is also the same as what I presented earlier. So these numbers, 3, -5, -2, they play an important role in identifying an arithmetic sequence, okay? Because this term are these numbers are the numbers that we add to the previous term to get the next term, okay? And that's very important. It is fixed. They should be equal. The interval should be equal for us to say that it is arithmetic. Otherwise, it could be a sequence but not necessarily arithmetic. Excuse me. And for arithmetic, the operation is addition. Addition of a fixed number or interval. We call this fixed number or interval as our D, okay, big D, or the common difference. Common difference. Okay, sir, why is it called common difference if we add the terms? Technically, that should be common sum. Okay, but now in this particular example, in a sequence, you can have a common sum. Okay. When you say interval, that means the gap, and the gap pertains to a difference, not a sum, because you do not add these two. You try to think of a number that would fill in that gap or that interval. Thus, it is called a difference. Okay. So now this one is called a D of this sequence. This is a D of this sequence. This is also a D of this sequence. Okay? Again, a common difference is a fixed number, whereas it is the number that you add to, it is a fixed number that you add to the previous term to get the next term. The next, and next. They should always be the same or equal. Otherwise, it's not arithmetic. It's just a mere, let's say, it's just a mere sequence, but not necessarily arithmetic. Okay? In the next video, we will be discussing other examples of arithmetic sequence. Okay?